Good morning everyone, myself Sanjeev Kumar.
Now we will solve a simple problem on calculation of armature current if speed and flux changes and the torque is going to be constant. If torque is constant, so flux, armature current either is to be changes, whereas if your back EMF is changes, flux as well as speed is to be changes. Now here speed and flux changes, so torque is going to be constant, so there is a change in back EMF. If back EMF is changing means, so armature current is also changes. Now the question is, a 220 volts DC shunt motor has armature resistance of 0.5 ohms and armature current of 40 amperes on full load. By how much main flux is to be reduced to raise the speed of motor to 42.5% if torque is going to be constant. So original speed, if you say original speed is N1, now the new speed is 42% greater, that means 142.5% of the original speed. Now the torque is constant. So speed increased, then torque is constant. So there is immediately change in the flux. Now flux, speed both changes, torque is constant, so armature current is also changes. So we cannot directly calculate flux, but in terms of armature current we can calculate. We know that, so T is proportional to pi into Ia. So since T is constant, we can take the two cases, so flux relations and armature current relations evaluate. And also EB is proportional to pi into N. Now flux, speed both changes, so back EMF is also changes. And back EMF is equal to V minus IAR. Now armature current increases, back EMF decreases. So by using these relations, we will evaluate what is the change in flux in terms of armature current. Why there is no initial flux or increase in flux is given, so we have to evaluate in terms of armature current, then it will be easy to understand. Now we'll go for the solution. Now the solution is given by given data. A DC shunt motor having V is equal to 220 volts. Now what is V? Supply voltage. Next, armature resistance. So armature resistance is RA, is nothing but 0.5 ohms, and armature current is given. So the main parameter armature current is given and it is 40 amperes and it is full load. Next, the flux. How much flux you have to reduce to increase the speed? So what is meant by this? Flux and speed both are inversely proportional. If flux increases, speed increases. If speed increases, flux is going to decrease. So that I am assuming initial flux is pi 1 and next increase in flux is equal to pi 2. Similarly, initial speed is equal to n1 and increase in speed is equal to n2. Now the speed in terms of percentages is given. So if n1 is 100%, now what is the change in speed? 42.5%. So the speed increase will be 42.5 plus 100%. Okay. Now if n1 is equal to 100% speed, now increase in speed n2 given by, so n2 is equal to 100 plus 42.5% into n1. So n2 is equal to 142.5% into n1, nothing but 1.425 into N1. Okay. Now this is in terms of percentages, but it is nothing but actual value is 1.425 into N1. Now speed change and the torque is going to be constant. So T1 is equal to T2. Let us say T1 is the initial torque. T1 is the initial torque. T2 is the increase in torque. But what is the condition? T1 is equal to T2. Now we have to find out what is the flux change. The change in flux, a ratio of flux we are going to find out. There is nothing but change in flux we are going to evaluate. Now see the first case when the armature current is 40 amperes. Now when armature current is 40 amperes, so let us say this is case 1. Now why I am considering armature current different? So we already discussed that EB is proportional to flux into speed. So flux speed both are changes. Now EB also changes. Now EB is proportional. EB is equal to V minus IAR. Now V is constant, so I is going to change. So that I have to calculate the armature current for both cases, if it is possible. If you know the any one case, so we will calculate that armature current, and that will give the relation. So T is proportional to IA. Now this relation evaluates the change in flux, the change in current. Okay. Now we evaluate. Now we are going to evaluate the back EMF for both cases. Okay. Now when armature current is 40 amperes, back EMF given by, so EB equal to V minus IA into RE. Now let us say this is IA1. Okay. Whereas IA1 is the armature current, nothing but initial armature current. Now substitute this value V and IA1, so V is equal to 220 and IA1 is given full load 40 and armature resistance is 0.5. Now what is the value for initial case? Now EB is equal to 200. Let us say this EB is equal to EB1. Now it is equal to 200 volts. Again, what is EB1? Now this is the case 1 EB1 when armature current is 40 amperes. Okay. Now we will take all this given data. So I am giving subscript 1 since the case is first case, that is initial case. Now EB1 is equal to 200 volts. So this is equation 1 I am giving. Now second case. Now case 2, if flux reduced, speed increased by 42.5%. Consider armature current is IA2. So I don't know the armature current in second case, so I am assuming it is equal to IA2. Then back EMF EB2. Now I am assuming back EMF is EB2, so EB2 equal to V minus IA2 into RA. So EB2 equal to V is 220 minus IA2 we don't know, so armature resistance is 0.5 into IA2. Now this is the value of EB2 and this is equation number 2. So EB1 is calculated and EB2 is calculated. Okay, EB1 and EB2. So EB1 belongs to 40 amperes and EB2 belongs to, so when flux changes, So speed also changes and the armature current is also changes. So I am giving Ia2, it's not 40 amperes for this case. Now if you know the two equations, and let us go for the current relations, torque relations and back EMF relations. Okay, now I'll write here. Since torque is constant, if flux and speed changes, so T is proportional to pi into Ia. Okay. Now T1 is the initial torque. We already know T2 is the increasing torque. So T1 is, we have T1 is proportional to pi 1 into Ia1 and T2 is proportional to pi 2 into Ia2. Now what is pi 1 and pi 2? Pi 1 is the initial flux and pi 2 is the increasing flux. Ia1 is the initial armature current 40 amperes we know, and Ia2 is the second, that means increasing armature current we don't know. Okay. Now this is equation number 3 and equation number 4. So equation number 3 and 4 equal, so torque is constant. Now T1 is equal to T2, pi 1 into Ia1 is equal to pi 2 into Ia2. So pi 1 by pi 2 is equal to Ia2 by Ia1. Now this is the equation. So if you know this, we can calculate the change in flux, and if you know the armature currents, it will be very easy. And we are having some other relations. If you see the relations, so EB is proportional to pi into N. Now EB1 is proportional to pi 1 into N1 and EB2 is proportional to pi 2 into N2. Okay. So EB1 is the 40 amperes back EMF, pi 1 is the initial flux, initial back EMF, initial speed. And increase in back EMF, increase in flux and increase in speed. So again you give the equation number 6 and equation number 7. Okay. Now dividing equation 6 by 7. So what we will get? EB1 by EB2 is equal to, so pi 1 into N1 by pi 2 into N2. But we want flux relations. So you know this flux relation. So what is this flux relation? Ia2 by Ia1. Okay. So this will be the equation number 8. Now substituting equation 5 in equation 8. Now pi 1 by pi 2 replaced by Ia2 by Ia1. So EB1 by EB2 is equal to, pi 1 by pi 2 is nothing but Ia2 by Ia1 into N1 by N2. Okay. Now you see this equation, we have calculated back EMFs. So one back EMF is in terms of armature currents, and we know the Ia1 and we know the N1 by N2 relation. So let us, I'm going to write in terms of EB2, that means the EB2 term will be the numerator. So rearranging equation. Now EB2 by EB1 is equal to N2 by N1 into Ia1 by Ia2. Now same equation, just taken into EB2 by EB1 is equal to N2 by N1 into Ia1 by Ia2. Now what is EB2? We calculate EB2 in terms of armature current 2 and EB1 is calculated, that is 200 volts. Now substituting EB2, EB1, EB1, N2, N1 and IA1 in above equation. So EB2 is nothing but 220 minus 0.5 into IA2 divided by 200 is equal to N2 by N1. So N2 is nothing but change in speed. We already written N1 is the initial speed, so N2 is 1.425 times of N1. So 1.425 N1 by N1 into, we know IA1 it is 40 and we know IA, we don't know IA2, so I am giving IA2 here. So we know N, we can also written as N2 is equal to 1.42 times of N1. Okay. Now you see here this N1 and N1 gets cancelled. We will have only remaining term is IA2. So remaining all unknown parameters are eliminated. Now you solve for IA2, you will get the value of IA2. So okay. So cross multiplying these two, you will get 220 into IA2 minus 0.5 into IA2 square is equal to 20 into 40, sorry 200 into 40 into 1.425. So you can see here minus 0.5 into IA2 square plus 220 into IA. So 44 into 2, 8000 into 1.425. So this 10 power 3 and 10 power minus 3. So you will get in terms of 824. So 11400. So you can see here. So you can directly multiply with the 8. So you will get 11400. So which is nothing but minus 0.5 IA2 square plus 220 into IA. Now you take into the left hand side 220 into IA minus 1140, and if you multiply with the minus, you may get 0.5 IA2 square minus 220 IA plus 1140 equal to 0. Now this will be the required equation to calculate the armature current. Now this equation, if you solve for IA, and this is a quadratic equation, if you find out the roots for this, you will get the IA value, that is nothing but, so this is IA2. So if you get the IA2 value, now you can calculate what is the value of pi 1 and pi 2. So that is pi 1 and pi 2 ratio simply. Now this is the required equation. If you solve for IA, we will get the flux relation, that means change in flux in terms of armature currents. Now solve for the IA2. So we know the quadratic equation roots. So it is given by minus b plus r minus b square minus 4ac by 2a. So I will directly write this equation in terms of quadratic. So the roots given by, so minus of minus 220 plus or minus, so I will write the b square, it is nothing but minus 220 square and minus 4ac. Okay, so what is the 4? What is a? 0.5 and 11400 divided by 2. Now which is equal to IA2. So IA2 is equal to minus into minus plus. So 220 square we can written as 48400 minus. So this is nothing but 22800 divided by 2. Okay. Now if we calculate this term 220 plus or minus under root. So 228 is nothing but 0, 0. So this is nothing but 56. It is nothing but 256 and 0, 0 by 2. Now 220 plus or minus 256 is nothing but 16 square. So this will be 160 divided by 2. Now this is the IA2 value. You go for positive value, you may get very higher value. So taking the negative value. So taking negative value, what you will get? So if you take the negative value, IA2 is equal to 220 minus 160 by 2. It is nothing but 60 by 2, which is equal to IA2 is 30 amperes. Now IA1 is 40 amperes. Now IA2 is 30 amperes. So armature current decreased. Now armature current decreased. What happens? Back EMF increases and flux decreases. So flux decreased in this case. So what happens? Immediately speed is going to be increases. So this armature current is 30 amperes. Now we have, so pi 1 by pi 2 is equal to IA2 by IA1. So since this relation is obtained by T is proportional to pi. Okay, pi 1 into IA1 equal to pi 2 into IA2, but pi 1 by pi 2 equal to IA2 by IA1. So pi 2 by pi 1 is equal to IA1 by IA2. So pi 2 by pi 1 is equal to, so what is IA1 value? 40 amperes, and what is IA2? 30 amperes. So which is nothing but 1.33. Now you can see here pi 2 is equal to 1.33 times of pi 1. Now what is the change in flux? That means this is 1.33 times of pi 1. Now what you observe from here, now the armature current, so pi 2 equal to 1.33 into pi 1, you can see here. Now how much main flux is to be reduced? That means this much amount of flux is going to be changed. Now this is the required equation. Now it is quadratic equation. Solve for the quadratic equation. So solving for IA2 in terms of quadratic equation. Quadratic equation, we know that quadratic equation roots are minus b plus or minus b square minus 4ac by 2s. I am directly writing, so minus of minus 220 plus or minus b square. So what is b again? Minus 220 whole square, b square minus 4ac. So 4 into a. What is the value of a? 0.5. c 11400 divided by 2a. So a is nothing but 0.5. Now minus into minus plus 220 plus or minus. So b square is 22 square is 48400 minus. So 4 into 1 by 2, 2 into 114 is nothing but 22800 divided by 2 into 0.5, so it will be 1. Now IA2 is equal to 220 plus or minus the root of, if we subtract 484 minus 228, it will be 25600 divided by 1. Now Ia2 is equal to, we know that 256 is 16 square, so double zero you get single zero, so 220 plus or minus 160 by 1, nothing but Ia2 is 220 plus or minus 160. So if you take the positive sign, it will be very high value, it may be nearly 380 amps. So in our this particular case it may not be possible, so taking negative value, so Ia2 is equal to 220 minus 160, it will be 60 amperes. Now Ia2 is equal to 60 amperes. Now the flux is going to be reduced to rise the speed by 42.5%. Now let us see how much flux is going to be changes. Now we have T is proportional to pi into Ia, so torque is constant. Now pi 1 into Ia1 is equal to pi 2 into Ia2, so pi 2 by pi 1 is equal to Ia1 by Ia2. Now pi 2 by pi 1 is equal to, we know Ia1, so it is 40 amperes and Ia2 is 60 amperes. Now you can see pi 2 is equal to 2 by 3 times of pi 1, so which is nothing but pi 2 is 0.66 times of pi 1, so pi 2 is equal to 66% of the pi 1. Now how much flux is going to be reduced? So the reduced flux is 34%. So you can see here this is 66% of pi 1, that means 100% pi 1 flux. So 66% now operating means, so flux decreased by, so flux decreased by 34%. The flux decreased by 34% and the speed increased by 42.5%, and the torque is constant, and armature current you can see here 40 to 60, this is nearly 1.5 times the current increases. So we can also see this case first. So T1 is equal to T2 in first case, that means case 1, what is happening? N1 is the speed and Ia1 is the armature current, it is 40 amperes, and pi 1 is the flux. Okay. Now in case 2, what is happening? N2 is the speed, that is nothing but 1.425 times of N1, so it is increased. Okay, the speed is increased. Now what is armature current? It is 60 amperes, so it is also increased. Now you see the flux pi 2, so pi 2 is equal to 0.66 times of pi 1, nothing but this flux is decreased by 34%. And you see the back EMF, so if you calculate the back EMF by using 60 amperes, you can calculate the back EMF also. So EB2 is equal to 220 minus 60 into 0.5. So you can see here 220 minus 30, it will be 190 volts. Now in first case it is 200 volts EB1, now EB2 is 190 volts. So you can see back EMF is also decreases. Now you can summarize. Speed increases, so armature current increases, and flux decreases, back EMF is also decreases. You can see, summarize from this problem, the motor speed increased by 42.5% and torque is constant. Okay. Now the armature current increases by 1.5 times and flux decreased by 33% and back EMF decreased by, so we can say that it is 5% decrease in the back EMF also. So like this, we can calculate the armature current and flux relations with the given speed and torque relations.